Hello, my name is Claire Madden, and I am the TMDL Tracking and Accounting Coordinator for the Clean Water Initiative Program at the Vermont Department of Environmental Conservation. This training will provide a demonstration of the Interim Phosphorus Reduction Calculator tool, which is a spreadsheet tool that has been developed to calculate estimated annual phosphorus load reductions for several types of clean water projects based on anticipated project implementation metrics. The tool is intended to be used by any clean water project implementer, as well as clean water service providers and basin water quality councils to inform project proposals and prioritization based on estimated phosphorus reduction potential and project level cost effectiveness. The tool is available for download at Vermont Department of Environmental Conservation's website. A link will be provided along with this video. The Directory tab of the tool has a list of project types and definitions for project types that we have calculator tools available for. This is a good place to start if you have a project in mind. Find the most representative project type based on the definition provided and navigate to the correct tool using the links in the table. The Stormwater Treatment Practice Calculator is a web-based application that is best resourced for calculating estimated phosphorus reduction for stormwater practices. This Excel tool has the ability to calculate estimated phosphorus reduction for riparian buffer plantings, bioengineered lake shoreline stabilization projects, floodplain and stream restoration projects, mitigation of gully erosion on developed lands with curbs and catch basins, forest road erosion remediation projects, and private road erosion remediation projects. The calculator tool is built based on the standard operating procedures for tracking and accounting that the Department of Environmental Conservation has published for clean water projects in the natural resources and developed land sectors. We have SOPs that detail the methods used for tracking and accounting for each of these projects, and they're available at the links on the directory page in the top left corner. A few things to note about the tool. This tool cannot calculate phosphorus reduction for stacked practices, which is the situation with more than one practice treating the same area. The calculation for stacked practices is not equal to the sum of individual practices, which would result in an overestimation of phosphorus reduction. Project types listed as options in the floodplain and stream restoration section of the tool are consistent with project types that were used in a model simulation as part of work done by the Functioning Floodplains Initiative to estimate median phosphorus reduction potential of various projects at the basin scale. This is not representative of every project type that may be available as part of a stream or floodplain restoration project. If you have questions or need more information, please contact the Vermont Department of Environmental Conservation Clean Water Initiative program. The methods underlying the calculations in this tool are subject to change, so please check back on the DEC website to confirm you're using the latest version of the tool. Tool releases will be version numbered to provide easier identification, and we will send out notification when new versions of the tool are posted. The values that are generated via calculations in this tool are meant to be used for project planning and prioritization. The Department of Environmental Conservation will calculate final phosphorus reduction values for completed projects after implementation. Let's go through an example of a riparian buffer planting. From the Directory tab of the calculator tool, scroll to the riparian buffer practice type and click on the link to navigate to the correct section of the tool. Alternatively, you can navigate through the tool by selecting the light blue colored tabs at the bottom of the screen. It's best to move from left to right through the input sections. If you get an error in the output, check to make sure all the inputs are filled in. Inputs are highlighted with a green header at the top of the table. You need to enter a project ID in the first column of each tab in order for the table to calculate outputs. It is also important that you start a new entry on the row directly below the previously filled row. Otherwise, the tool won't auto-complete outputs. Start with your project ID. If the project is already in the Watershed Projects database, we suggest using the WPD ID number, but you can use any unique identifier you like. Next, select the TMDL drainage area that the project is located in. If you don't know the drainage area your project is within, follow the instructions for using the Agency of Natural Resource Atlas to find the name of the TMDL drainage area. Next, enter the number of acres planted with buffer planting. Select from the drop-down list the most representative land use category for the buffer area prior to planting. Land use definitions for the 5 available land use categories are provided in the tool. Select the most representative land use that is consistent with the land use of the area of the project. Next, select from the drop-down the drainage area land use. The drainage area for a buffer planting is defined as 5 times the area of the planting directly adjacent to the planting. You may enter up to 3 different land uses and must enter a percentage of the drainage area for each land use selected. The total percent drainage area column is an user error check. It is important to confirm that this value is 100%. If it is not 100%, the drainage area percent land uses need to be adjusted to add to 100%. The output values are now calculated for the riparian buffer based on the specifications entered in the tool. The 2-acre buffer planting has a 10-acre drainage area associated with it. The estimated phosphorus reduction from treatment of overland flow originating in the drainage area is 0.95 kilograms per year, and the estimated phosphorus reduction resulting from land use change of the buffer planting area is 0.41 kilograms per year, resulting in a total estimated phosphorus reduction for this project of 1.36 kilograms per year. The other tabs of the calculator tool are structured in the same format as the riparian buffer and should be completed in a similar manner. Follow the instructions on each tab for specifics on what to include in the inputs, and be sure not to edit the outputs of the tool. The cost effectiveness tab of this calculator tool provides an opportunity to compare cost effectiveness of various projects using the cost effectiveness equation designed for formula grant project prioritization. The equations used in this tool are listed in the top left of the tab and are subject to change following public notice of Act 76 guidance. To pull in a phosphorus reduction calculated in one of the tabs of this spreadsheet tool, enter the project ID and the type of project, and the table will autofill the estimated phosphorus reduction that was calculated. Next, enter the total estimated cost of the project, including all design and construction costs. This tool provides an opportunity to compare cost effectiveness of the entire project cost, as well as the cost of the project that is estimated to be covered by formula grant funds. For the riparian buffer planting example we have walked through, perhaps the total cost of the project is $10,000, and $9,000 of that will be covered under a formula grant, with the remainder to be made up by match funds. The calculated estimated phosphorus load reduction that we worked through in the example is now in this table, and the total project estimated cost effectiveness as well as the formula grant estimated cost effectiveness are in the final two columns of this table in dollars per kilogram per year. The cost effectiveness table in this tool can be used to compare cost effectiveness among many projects as one component to inform project prioritization and selection by basin water quality councils and clean water service providers.